ENCLAPSലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Welcome to the wonderful world of physics. Current is an integral part of physics. Like this fan, there are many devices that run with the aid of electricity. Let's see some of them. Bulb, electric heater, mixer, storage battery, induction cooker, etc. Although we give them electric energy, they give us many other forms of energy. According to the law of conservation of energy, energy can neither be created nor destroyed, but it can be transformed from one form to another. Oh, aren't we creating electricity over the dam? Is it possible to produce energy like this? Now, let's analyze the path how current reaches us. When water flows into the dam, the water particles are in motion. They acquire an energy called as kinetic energy. Being trapped in between the walls of the dam, now they are at a standstill position. The kinetic energy gets transformed into static energy. Later, they flow through a long pipe called as penstock. Did you see any change here? Is there any difference from the initial state? Yes, it is. In the initial state, the water particles were at a standstill position and they had a static energy. As they flow through this long pipe, the energy is transformed to kinetic energy. Later, this water rotates a turbine which is coupled to a generator. The kinetic energy of the flowing water rotates the turbine and converts to mechanical energy. And finally, we get the output as electricity. The main factor to be noted here is that the energy is transformed from one form to another. Now, let us see the uses of some equipments and how the energy transformation takes place. A bulb used to receive light. What does it do actually? It converts electric energy into light energy. The induction cooker that we use to cook food converts electric energy into heat energy. The storage battery used to store charges converts electric energy into chemical energy. Mixer used to grind food converts electric energy into mechanical energy. The fan used to receive air converts electric energy into mechanical energy. From this, it's clear that electric appliances are converting electric energy into many other forms of energy. Therefore, the conversion of an electric energy would be the actual output of the device. If so, the output of a bulb is light energy, of an iron box is heat energy, mixer mechanical energy, fan mechanical energy, battery chemical energy, induction heat energy. Now, let's learn more about the thermal or heat effect of electric current. Have you ever noticed an iron box, heater, soldering iron, etc.? These electric appliances that we use in our day-to-day life give out heat. How does this electric energy get transformed into heat energy? Here, a nichrome wire is connected to a 6-volt battery by using wire and a switch. When the switch is turned on, the current flows through the circuit. The nichrome wire starts heating up. According to the law of conservation of energy, electric energy is transformed into thermal or heat energy. Let's analyze the circuit. Where R is a resistance in the nichrome wire, the voltage between the resistance R can be measured with a voltmeter and the current in the circuit can be measured with an ammeter. Let's look at another thing which is much more familiar to us. Here, a pump pumps water to the top of a tank and returns back. This means that the water is constantly flowing. When the pump is turned on, here we measure the amount of water flowing per unit time. This same phenomena is used when an electric current or energy flows through a conductor. Like the movement of water particles, the current is a flow of electrons and the charge is the mass of electrons. So, the electric current is a flow of charges. Current is the amount of charge flowing through a conductor per unit time, which is similar to that of the amount of water flowing through a pipe per unit time. Current is equal to charge divided by time. The unit of current is ampere, represented by capital A. The instrument used to measure current is an ammeter. In terms of character, current I is equal to Q divided by T. Then the charge flowing through the conductor in time T will be Q is equal to IT. The unit of charge is coulomb. Here, in the first case, the pump worked to deliver water from one place to another. Similarly, in a circuit, a cell carries charges from one place to another. This action is a potential difference. That is, the potential difference is the work done in order to move a charge from one place to another. A cell or a battery is a device used to make this potential difference in a circuit. Potential difference is equal to work done divided by charge. That is, V is equal to W divided by Q. The unit of potential difference is volt, measured by using voltmeter. The unit of work done is joule and unit of charge is coulomb. Now, if you write it in the formula, we get V is equal to W divided by Q. In terms of unit, V is equal to J divided by C. Here the potential difference is 1 volt when the work done is 1 joule and the charge is 1 coulomb. That is, the potential difference between 2 points will be 1 volt if 1 joule of work is done to move 1 coulomb of charge from one point to another. The potential difference is derived from the equation V is equal to W by Q. That is, W is equal to QV. W is a work required to move a coulomb charge from one point to another through a potential difference V. But since the current I is equal to Q divided by T, we can write Q is equal to IT. Substitute the value of Q in the equation W. Then W is equal to ITV or W is equal to VIT. In a circuit with a nichrome resistor, the battery's electric energy is converted into heat energy, which means that the work done by the battery is converted into heat energy. So, we can replace the work done W with heat H. Then what would be the formula? W is already equal to VIT. By replacing it with the value of H, it becomes H is equal to VIT. Therefore, a heat is developed since the current is available in the circuit in accordance with the voltage applied. Moreover, we are yet to learn 2 other equations to find out heat.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ Enclaps, the learning app.